Hi, folks. Welcome to another episode of Film Study. This is Ken McCusick. Have a really interesting topic to you today. I've been waiting for now about a week since I saw this on Twitter. Really wanted to talk to these guys. We have today with us Judah Fortgang and Arjun Menon. They're here, both University of Michigan students, correct? Nope,
Only me, only
only you.
Arjun.
And
Yeah,
more importantly, both PFF interns currently.
that's right.
All right. Outstanding to have both of you. And the two of you came up with something that is just very interesting to me, a QB decision-making metric. And I'm dying to dive into this, particularly on the methodology. And you know from being on the show several times before, Arjun, that we can get into some pretty good questions in terms of what's going on. And we certainly love to hear from you whenever we can about the next new cutting-edge thing you're coming up with. First of all, Twitter handles for both of you.
Yeah, for me, it's Arjun Menon 100. So that's ARJUNMENON, and then just 100 after that.
Yeah, and for me, I'm throw the damn ball, spelled without the N, because I could not get the domain name with the N. So throw DAM ball.
All right, very good. Great to have you both on. Let's move ahead to your presentation here. This is one of these rare ones where we actually have a presentation. Oops, sorry about that. Instead of just a discussion, which is normal on film study. But I'll have lots of questions as you go through this. And please tell me about your new metric.
Yeah, so I'll start us off. So basically, like Ken explained, we attempted to try and quantify QB decision making. So why did we do that? So basically, me and Judah kind of understood that football analytics has done a pretty good job of evaluating quarterbacks in the NFL and coming up with ways to evaluate performance. We have PFF grades, PFF WAR, EPA per play, which I think the industry standard in football analytics. Like most, if not all, NFL teams use EPA, or also known as expected points added, to evaluate team success and QB success to an extent. ESPN has QBR, Sports Info Solutions has total points added. So all of these metrics are kind of these all-encompassing metrics to measure production. So we weren't trying to focus on production-based evaluation of quarterbacks. Instead, we wanted to try and evaluate decision making, since that's a facet of QB play that really hasn't made a lot of rounds in the public, simply because there isn't data available to the public as there is in places like PFF or Sports Info Solutions. So seeing that we had all of this data to work with, and seeing that me and Judah have been interning at PFF for over a month now, that's the direction we decided to go. And after a couple of projects we were working on with secondary play, this is the direction of evaluating quarterbacks we wanted to go to.
Okay, so let's talk about the additional data that PFF has that the general public has. Is this dot type data where you have position on the field and seconds from the snap, et cetera, et cetera?
Yeah, it's mainly the stuff that PFF sells to teams, and it's that kind of data where it's like kind of exclusive to people who work at PFF and people who work for teams. It's just, obviously can't really release all of that information to the public.
But we're not talking about the XY dot data that.
Oh no.
Okay.
That's tracking data. Me and Judah actually we're going to fold that type of data in to our model eventually. The interesting thing about our metric is that it was attempted a couple years ago by someone named Matthew Rayers, and Matthew works for a company called Zelus, which is a sports consulting data company. So they actually work with a couple NFL teams. Matthew attempted to make our metric with only 6 weeks of tracking data and exclusively tracking data. So I think, we haven't been able to really see how well the metric has held up, because we only have 3 years of data. So that making bigger assumptions off of that is tough. But it was cool to see how our metric and Matthew's metric lined up, and eventually folding and tracking data will help the metric, as we'll be combining both charted and tracking data into our model.
So his 6 weeks of data was done for probably big data project, because I remember they gave away 6 weeks of data for that.
Exactly.
Okay.
It came from the Big Data Bowl in, I believe, 2019.
Okay, it's a great idea, but you guys do have 8 times as much data with 3 years. If we're talking 48 or 49 games relative to 6, so you're in a lot better position to evaluate what you've got.
Yeah.
All right. Well, let's move on with the methodology then.
Yeah, so I'll take it from here. Basically, the idea was with the sort of data that we have, which tracks each receiver and each cornerback on a given play, we can kind of assign a value to what the quarterback would have done had he thrown to that receiver, which I think is part to your question before about the type of data that we have that publicly is not available, just grading each receiver and each cornerback on a given play. So first, we built sort of a completion probability model because in order to first uh, kind of get a sense of the predicted EPA and apply the predicted expected points added, you first need to know, okay, how likely is this pass to be completed? Because if we didn't have that, then the model would just assume a completion where there was not a completion, and instead there were differing probabilities. So that's kind of the first step. And then from there, with the with the completion probability, we can develop a model which says, okay, if Tom Brady threw to Chris Godwin at this route depth with this kind of coverage on him, his expected points is X. On the same play, Mike Evans is running a different route, and his expected point value is Y. And we can say, is Tom Brady making the right decision?
I think sometimes the best thing I can do in this situation is to try and parrot back what I think you've said, and then you tell me what went wrong here. But if I understand that, then you have a receiver on cornerback matchup, so that plays a factor in how many expected points are involved. Then you have a route depth, and you may have enough data for each receiver and corner at that route depth to put that together, or how does that play into it? Is it just a separate factor that's not considered on a second level of data? It's not compound data right there.
So you were right. All of the data is incorporated there. It's essentially saying on a 7-yard post, given all of these different factors, the game factors, the matchup, the route type, based on what did happen in the past, what can we reasonably say will happen in the future?
Okay, so game factors would include what? Down and distance?
Down, exactly. Down, distance, time left, other sorts of factors.
Okay. All right. Outstanding. What about other elements of deception that are involved in the game? So does this methodology do a good job with, say, play action concepts or how the backfield is lined up, things like that?
Exactly. So we included things like whether it was play action, whether it was a run pass option, the personnel groupings, how many receivers were on the field at a given time. So it's really getting a lot of sort of the variance, not everything, but it gets situational factors, personnel factors, and all of that is incorporated into building this model.
Okay, so far I'm liking what I'm hearing. I'd say there's a little bit of a black boxish component that we can't actually see the data to look at this. And I understand why that is, of course. What about like if the opposing defense is playing a dime linebacker as opposed to a traditional will? Is that considered in the methodology?
Yeah, so that's included as a factor in the model. All of those things, the scheme of the defense, the kind of the personnel groupings, all of that is included.
All right. Well, very impressive so far, guys. Let's keep going.
Terrific. So then from there, okay, we have a predicted expected point had the quarterback thrown that pass. Now the question is, how does that kind of correlate to different offensive success metrics? So initially, our assumption was that the more you make an optimal decision, that is, the more the quarterback throws to the most open guy, it's likely that that's the better the quarterback will be. And in essence, we can kind of derive how good a quarterback is based on how often he is making the right and optimal choice. But it turns out that wasn't really the case, and that doesn't really correspond so well to EPA, which I think on the surface is a little bit striking. But then you think about it, it makes a little bit more sense because a quarterback's not always throwing to his wide receiver one. More often than not, he's actually not going to be able to fit that pass in. It's what happens when he's hitting his second receiver or his third receiver. How well he's doing when the defense is kind of covering up the number one option that's going to most affect his EPA and how well he's playing. So from there, we kind of took if we move ahead to the predicted EPA stuff and the worst and best quarterback decision making is we can in the aggregate take which quarterbacks made the best decisions, which is in essence saying that a quarterback has all of these receiving options available. When he does make a throw, what is the expected point total that he is almost setting up for himself? Tom Brady, right, as you see in the top right, is more often than not throwing to the right receiver than is Mitch Trubisky, which is saying that he's throwing to the right receiver more often. He's making the right decision by throwing to the right guy.
Okay, so this is a slide I definitely have questions on. So the dotted line that's down there is obviously some sort of league average for EPA per pass, or is that for EPA of the available? No, it's
That's right.
tell me
No,
what
that's
it is.
right. That is the each quarterback, right, has an assigned value of the prediction of the throw he's making, which is to say that he has 4 receivers open. The mean value on that play is going to be whatever it is. Let's say 0.12, and then if you took all of the plays, it's going to spit out this number, which is the mean. So 0.12 might be one play, but over the course of a season and 500, 600 plays, that mean value is going to be 0.13. When he's making a throw, he's expected to have 0.13 expected points ahead.
Okay, so if we're looking at Tom Brady's big win over a standard EPA number, some of that is obviously in the quality of his receivers and the quality of his 5 choices that he has, assuming 5 eligible receivers on the play that he has, and some of it is in the proportion of the time that he throws to the highest value receivers as you would score it.
Yes. So of course, different kind of receivers and schematic factors are involved, and that's something we're trying to build on as we work forward in this project, which is kind of seeing how much of this is the quarterback, how much of this is the scheme, how much of this is the receivers. All of these are questions we're addressing.
Okay, but anyway, starting with the quarterbacks versus a league average set of receivers, assuming everybody's scheme and offensive line and all the other elements are equal, is a great place to start on. And what this graph should tell us is that the guys at the very top are throwing to their highest value receiving options the most.
Yeah. So it's the difference between a rate versus an average. So the rate we found is not such a huge difference, which is to say, Tom Brady might not be throwing the optimal way 30%, but in the other 70%, his number 2 and number 3 options that he's hitting more than makes up for the fact that he's not the optimal decision maker, meaning that he's not making an optimal decision 35% of the time, but the value of the other 70% of the time or the other 65% of the time kind of puts him in that place.
All right, very good. Now we see Lamar Jackson is ranked 3rd here on this metric. Can you break that down to us into some supporting factors?
Yeah, I think with Lamar, it's a matter of, first off, I think his scheme does a brilliant job. His receivers also do well getting open on average, which I think is actually maybe not necessarily the most, I don't know. Yeah, but it's in essence saying that like he's finding the right guys most often. His scheme is dictating that he's throwing to Mark Andrews on the 17-yard seam route, as opposed to someone like Drew Brees, who you'd find lower down, who's just throwing the 7-yard slant no matter what. And whatever the factor is, the reality is that Lamar is kind of finding his receivers and making the better decisions more often than the rest of the league.
Now, one of the things that came up I in our production meeting, but I didn't think it really came up in the show, is you guys are judging this all at a point in time. So it's at the point in time the ball is thrown, as opposed to what windows opened up during the play, which would seem to me to be a much more complex problem.
Yeah. I can take this one. I think, like, if we were working with tracking data, I think ideally it would be the time or the point in time where the ball was thrown. Since we're working with charted data, we're not really working with time. It's kind of just working we're really working on like at the point that the ball is thrown. I think that we are working with that. It's just, it might not be like an exact science, just because when we're working with some of the route data, the route depth is charted at the point of when the ball is thrown. So, when Mark Andrews is running like a 17-yard seam, and like go routes are traditionally like hard to chart, especially since like the distance from the line of scrimmage to where they're running the seam is a little bit arbitrary. You kind of have to do a little bit of guesswork on that. But yeah, our metric is kind of based on at the point where the ball is thrown.
Okay, so one thing comes up, and this would kind of be something that I think would artificially inflate Jackson, if anything. I know Ravens fans probably not going to want to hear this, but the way that Lamar, just two things, Lamar extends plays, he may be getting a higher value set of options as time moves on. But maybe more importantly is, since he's not a traditional check down quarterback, he's his own check down. Those runs, do they get taken out of the denominator, or are they somehow included in one of the options as decision makers?
So the runs do get taken out, only because this is tracking the actual throws of the that a quarterback makes. But I think that point still holds, which is that he's kind of buying time for himself, and where other quarterbacks might throw the ball where they shouldn't, he's actually just running. Right. So,
and that's good.
Yeah, exactly. That's going to raise his
in our initial article that we wrote about our concept of perfectly covered plays, Judah actually found that like when a defense perfectly covers a play, running is the only option where it nets a positive result for the offense. So mobile quarterbacks are exceptionally important in these type of plays. So even if Lamar is taking off and not throwing to a receiver, he's going to net a positive result more often than not. And I think that obviously doesn't show up here, but he shows up so high here that you'd have to imagine that on top of making good decisions, he's also putting his offense in good positions to succeed.
Okay, that's really good and interesting to hear. So, you mentioned Drew Brees, but one of the things that comes to mind with the Saints game is a lot of checkdowns and a lot of screen passes. If I think back to the Ravens, I'm thinking back, of course, to Joe Flacco and Ray Rice and their connection, and how he would have had a lot of, read one, read two, dump to Rice kind of plays that probably would not make him look particularly good by this metric. Where would you guys, just predict? I know you've only got 3 years of data, so it doesn't even include Flacco, but where would you even predict that he would show up based on that?
I mean, he's probably like a below average quarterback, so he'd be to the left of the dotted line. If I didn't really watch too much Joe Flacco back then. I wasn't as in tune with football as I was now. But if what you're saying is correct, and he's going to his check down instead of taking the reads more downfield, he's going to end up where a guy like Drew Brees is, because some of the other routes that he's running are going to have a higher predicted EPA, and the check down is going to have a lower predicted EPA. So you'd probably find him in like the Drew Brees Tua range, which isn't obviously good for the Ravens.
Okay. All right. Good. That's very good to understand. It's also very humbling to realize, I'm 59 now, and I'm talking to a couple guys who are 21, 22, 23 years old. Are you guys even that old?
20.
Jeez. Okay. So Joe Flacco's 2012 season, you were 10. And so you really missed some of that. I'm just guessing.
Yeah.
So, all right. Well, anyway, really appreciate this. Great stuff. You have more to show us, though.
Yeah. And real quick, before we hop into the next draft, I want to actually shout out Lamar Jackson, because he actually did see our work on Twitter. When Judah posted this graph on his Twitter account, it kind of blew up, and Lamar kind of quote tweeted someone who quote tweeted Judah. So it was kind of cool for both of us that we had someone with someone of his following see our work and kind of enjoy it.
Very cool.
Yeah. So this next graph is basically looking at how well quarterbacks perform after making their decision. So in essence, we called it QB execution EPA, but to be more precise, it's basically EPA over expected. This is saying that given the decision they made, how well did they? So this is basically taking the actual EPA on a play and then subtracting the predicted EPA from our model, and that is the result of what this graph shows. So for someone like Drew Brees, and I think this really captures well like why Drew Brees showed up so low. Drew Brees always was taking the short underneath stuff later in his career, but because he was such an accurate quarterback at that point in his career, even when the predicted EPA was low, he was still making positive plays because he was able to fit balls in the tight windows, even though it wasn't that far down the field.
Okay, so if I can again use the parroting tailback method to just make sure I understand this. So Tom Brady throws a ball to Gronk and it has an expected value of 0.5 expected points, let's say, but his result and Gronk's result is 0.7 because of whatever reason. The play gains 20 yards, and that's a 0.2 net on this. And this is the per play point net right here. I'm looking at.
Yes.
Okay. All right. And so it looks like the average league quarterback did worse than expectation by about 0.08 points. Is that correct?
Yeah, about 0.08.
How can that be? How can the league average be that much below expectation with expectation being correct?
So I think it goes a couple ways. Number one, the way we applied the model, when we're predicting EPA, we're predicting EPA on all types, on every single route on a given play. So I think the EPA value there, the model EPA values are going to be a little bit inflated for some of the routes that have a high frequency of turning into like explosive plays, so like go routes and seam routes. So when the offense underperforms in those type of routes, I think that's why it turns out to be negative.
All right, I'm not sure I really heard the answer there that I can latch onto. As an actuary, I really do expect the data on average to be average. And so you're telling me there's something about the way the model is defined that inherently biases the expectation to something lower than 0.
Judah, can you take this one real quick?
Yeah, I think also there are kind of, I'll say it 2 ways. I think there are I actually think this graph's a very helpful way of framing it. That basically what we came to is that there are almost 2 ways to win as a quarterback. And I'll tie on your question at the end. The first is that you can be really good kind of with your mind, saying, I'm going to make the right decision. Tom Brady is not the best thrower of the football, but he's best at recognizing where the best place to throw is. And that is a skill in and of itself. The second thing is your ability to throw the ball well, which is kind of this execution relative to decision graph we see, which is Drew Brees might not be making the best decision. At least this is the later point of his career, which I think is an important point to note. But he's really good at throwing the ball, that it actually makes up for what he lacks in his decision making. So the argument, even if it's not the model, might be saying that NFL quarterbacks are on average better at making kind of the right decisions with their mind, let's say, but aren't actually as good throwing the ball, which might be surprising, but it could go either way, which is that in order to make it, let's say, to the next level, you actually have to be better at recognizing a defense than you would be at actually throwing the ball. That's at least one way to interpret it.
Right. I can understand that there would be. Yeah, I think I'm having trouble with that one statistically, just understanding why that would be true. But you guys, I'm sure you've done the right things in terms of putting this model together. Maybe we talk about that one offline a little bit. But I appreciate this, and what else do you glean from this slide relative to Lamar Jackson?
Yeah, so I mean, Lamar, he shows up near the top. He's not as high as he was before. I think part of the reason he might drop is he doesn't really have he didn't really have that great of a receiving core in the past 3 years. So even if he's making optimal decisions where he's putting his offense in a good situation, his receivers, and this is part of why EPA is tough to use as a quarterback stat sometimes, his receivers would let him down. We saw the amount of drops Hollywood Brown has had the past couple of years. I mean, the Lions game where he dropped like 3 touchdowns, I mean, those predicted EPA numbers are like, obviously I don't have the raw numbers, but those predicted numbers are probably in like the 0.6, 0.7, and Hollywood Brown dropping them instantly turns it into a negative play by this EPA over expected metric. So, for Jackson, I think it's important to look at the process, which was the previous slide, and then the results might not just be a Jackson application. It can also be an application to the type of players and receivers he had around him, which is why he dropped down a little bit.
Makes sense. So great yak players help out their quarterbacks, and maybe even great scheme if you can peel the top off the defense and create extra yards for your tight end or whoever's running underneath. Okay, that's great stuff. Well explained. What else do we have here?
Yeah. So I think we were kind of getting into this before. Basically, this graph shows three things. It's the two parts that we've broken down, and if you add up the totals of each of the axes, you actually get the EPA, which means that Aaron Rodgers, right, had a decision EPA, meaning the choices that he made in the position he put himself in was 0.22, and his execution was a little better than that. I actually don't have the exact numbers in front of me. His execution was a little better than that. So his EPA, let's say, will be 0.24. That's kind of a way to first interpret the graph. And I think this is kind of what we were saying before, that really the point to drive home is that quarterbacks can win in multiple ways. And the almost expectation that you set for yourself through the predicted EPA kind of allows you to then execute on that. And how well you execute, I think it's cool to note one of the better findings that we had actually better predicts your total EPA in the next year, which is to say that how good you are at throwing the ball, whatever goes into the executed EPA, will do a really good job of predicting your total production for next year.
Okay, so the upper right corner, upper right quadrant, which are the good decision makers who are also good execution players.
That's right.
They're the buys, or is it specifically the good decision makers who are better buys than the good execution?
So you want the good the execution ones, but it's also all relative to where you started, which is the prediction, right? So you could be a really good executor. Your predicted EPA, let's say you're 0.1 execution. There isn't actually a great example of this on our graph, but we could play the theory here. But your predicted your decision EPA is 0.003, and your execution EPA is 0.002, which would be really, really good. You're still getting an EPA of 0.05, so that's not really helpful. So in essence, you want to have both, of course, but it's almost a framework. The decision EPA allows you to properly understand the execution EPA, which in turn is a great predictor of your total performance.
All right, let's look at Deshaun Watson for a second, and how would you evaluate what he's done here? Because it looks like he's a little bit below the average in terms of decision making, and above average in terms of execution.
Yeah. So Watson, I mean, the thing with him is like he's a pretty accurate quarterback. So even if he's not making the optimal decision most of the time, he's able to execute on them by his accuracy and completing passes, which in turn will lead to a positive EPA more often than not. It is pretty curious because in that Texans offense, I did feel like a lot of his stuff came down the field for him, but obviously the model thinks things in another way. So I think Watson's position on the graph was definitely a little bit surprising, but given the type of quarterback he is and how accurate he is in metrics like completion percentage over expected, I think where he shows up is pretty fine.
All right. In terms of you did have one more slide to show us, right?
Yeah. Do you want to head over to that? Okay. So this I think the graph is a little bit small. I thought I fixed that, but this was a pretty straightforward graph. This is basically saying when the quarterback throws to his optimal read, how well is he performing, and then when he doesn't throw to his optimal read, how well is he performing? So the way we obviously defined optimal was the receiver on for any receiver on a given play, the receiver with the highest predicted EPA from our model would be deemed optimal because he would net the offense the most expected points, or he would net the offense the most positive points on a given play. And then obviously non-optimal is every receiver that wasn't the most optimal. So that's kind of how we put this graph together. For Lamar Jackson, he shows up in the quadrant that you want. Above average when throwing to his optimal read, above average when not throwing to his optimal read. So I thought this was a pretty neat way of like tying together all the work that we've done and putting together some of our model outputs on one graph.
Yeah, this is a fascinating graph to have because you wouldn't necessarily separate this. You might have just receivers 1 through 5, and percentage of went to each, and then the value of each, and that would be enough. But this gives you another layer to this. Is there some Hollywood Brown and his drops showing up in this? Would he have likely been the optimal read on a lot of those deep throws that got dropped, particularly in the Detroit game?
So the thing with this metric is it's not actually, this has nothing to do with what actually happened on the play. This is all just the predicted outputs from the model.
Gotcha.
So this isn't affected by drops, or this isn't affected by fumbles that can happen after the catch, which are included in some, but not all EPA models. So this is purely looking at quarterback decision making and separating everything else from that, and saying when the quarterback makes the right read, is how well is he putting his, or how, in what position is he putting his offense, and when he's not throwing to the correct read, or when he's not throwing to the optimal read, how the good or bad is the offense going to be, or what position they're going to be in.
All right, very good. You would expect the axis to meet on this graph at a point where the optimal read had significantly more EPA than the non-optimal read, right? And that's good. It does. It looks like it's about 1.08 and minus, or right around 0, maybe.
Yeah, it's pretty significant. It's like, basically our model was saying that like when a quarterback's making the optimal read, they're going to gain a point on average, which is like pretty crazy when you think about it.
So a point on average, and lose about 1/10 of a point when they throw to a non-optimal read, right?
Exactly.
About what percentage of throws went to the optimal read in the modeling you did?
I believe the highest number was actually Cam Newton. But like we said, the rate at which you throw to an optimal receiver doesn't really matter. So we took it with a grain of salt, but I think it was around like 45%, right?
It was 25 to 35%.
Oh,
they're all pretty clumped together.
Yeah, too high.
Okay, so let's say the average in the NFL is 30%. Then if I take 30% of 1.08, I get 0.33, roughly, a little bit under. And then if I take 70% of minus 0.09, is that correct? Or is it minus 0.04? My eyes are not good enough to read that graph right now. Okay, so let's say it's 70% of that is minus 0.035. So does that work out to the EPA per play in the NFL being pretty close to 0.3?
I think so.
Okay. All right. Well, guys, fascinating topic. I wish we could look more at the data you were using to do this, but I do understand why that's not allowed. And it's still great to have you guys explain it, and the methodology and the relative features of this, just very interesting. This is the kind of topic that never gets any kind of a deep dive in terms of methodology, and I appreciate you giving us at least a shallow dive into methodology in the time you could do this. This seems like a fairly complex model in terms of how it would be put together, and I guess there's a lot of the devil in the details would be in how you're looking at cells with limited data on receiver, route, and depth combinations, for example.
Yeah. We kind of use like an extreme gradient boost model. It's called XG boost. So it's funny how you mentioned like the black box stuff, because like XG boost is a black box model. So we don't really see what happens while the model is running. We just work with the outputs. We can obviously see what factors are important when creating like the completion percentage model or the expected EPA model. But yeah, I mean, this project took us probably like a week and a half from start to finish. So, obviously it was really fun working with Judah, and I'm glad we were able to put this together in an article, and I'm glad you brought us on to talk about it.
Always a pleasure talking with you guys. And, one of the things I always say is football doesn't have good control groups. So whatever you are, you're maybe not looking too close at how the black box is evaluating what an expectation might have been in terms of the very limited data it has. But that's this is very fascinating work, guys. And anytime when you have this kind of project, I'm interested to bring you on the show and have you talk methodology, because that's what I really love to do. So tell folks where they can find your work and where they can talk football with you online again.
Yeah, so you can find all of my work at pff.com, and you can find me on Twitter at throwthedamnball, dam spelled DAM.
Yeah, same thing with me. You can find all my work at pff.com. And my Twitter handle is at Arjun Menon 100. So, excited to keep this ball rolling and keep updating the model.
All right. Outstanding, guys. Other folks out there, if you'd like to be on a film study short, hit me up with a DM on Twitter. They're always open. Always looking for good analytics work, but it doesn't have to be this. Any narrow topic about the Ravens you'd like to discuss with me in about 25 minutes is ideal for this sort of thing. And I'd love to hear from you. I'll get back to you very quickly. Guys, Judah and Arjun, thanks so much for coming on. Really appreciate having you here.
Thank you.
And we'll talk to you next time on Film Study.